AQA Level Chemistry Paper 3, June 2020. Question 1.1. Explain how oxides of nitrogen are formed in engines. Nitrogen and oxygen from the air react at high temperature. And the high temperature part is really important. You can say nitrogen and oxygen from the air react. That's 1 mark at high temperature. State why it's desirable to decrease emissions of oxide nitrogen from vehicles because the formation of acid rain / causes respiratory problems. Give the oxidation rate of nitrogen each of these. So nitrogen this, well, oxygen minus 2 times by 2, so it's going to be plus 4. Nitrogen, hydrogen, so nitrogen is going to be minus 3 because hydrogen is plus 1 times by 3 plus 3, so it's got to be minus 3 to get over charge 0, and then nitrogen in this case can be 0. Then just balancing the equation. State the meaning of the term heterogeneous catalyst. Catalyst is in a different phase / state to the reactants. Speeds up reaction without being used up. Now, you have to realize how many marks it is and what you need to say. If you just say catalyst is in a different phase / state to reactants, you won't get 1 mark, and then therefore it speeds up the reaction without being used up. It's a catalyst, and that's your 2nd mark. Some carbon particulates also formed in both diesel and petrol vehicles. Explain why carbon particulates are formed in complete combustion. State why both oxides form alkaline solutions. Suggest why sodium oxide forms a solution with a high pH and solution formed from magnesium oxide. Oxide ions react with water to form hydroxide ions. Sodium hydroxide is more soluble than magnesium hydroxide, therefore forms a solution with a high pH. Given the equation reaction between phosphorus 5 oxide and water, P4O10 plus 6H2O to form 4H3PO4. Give 2 equations. Vanadium oxide acts as a catalyst process. V2O5 plus SO2 to form V2O4 plus SO3. V2O4 plus a half O2 to form V2O5. Oh yeah, I can't go through this one. I would love to go through this one, but yeah, because it's calculation based question. 3.3. Describe how a calibration graph is produced to find concentration of this. Measure absorbance for a range of known concentrations. Plot graph absorbance with concentration. Read value of concentration for the measured absorbance from the graph. Calculate mass in mg in milligrams of the ion used to make this much solution. So moles of concentration and volume. You get the moles. The moles is mass over mr. Mass is going to be the moles times by mr. But I want it in milligrams, so I've got my answer in grams. I want it times by 1,000 to convert it into milligrams. Name process that prevented by cisplatin during cell division, DNA replication, and I give the equation. PTNH3 2Cl2 plus H2O form PTNH3 2ClH2O plus Cl minus, and remember square brackets for the first one and the third one. Complete figure 1 to show how the platinum complex forms a cross-link between guanine nucleotides. So you form all the information is there, and you just draw out PT, H3 and NH3, lone pair of nitrogen going to the PT. Explain how graphical methods can be used to process the measured results to confirm the reaction's first order. Plot concentration on the y-axis against time on the x-axis. Take tangents and calculate gradients to calculate rates. Plot rates / gradients against concentration straight line through origin, therefore first order. Complete table 1. Just complete table 1. 1 over T, ln K. And then plot the graph. And then it says calculate activation energy in kilojoules multiplied by minus 1. So finally a calculation question again. So, well, what I need to compare it to, because it's a straight line, this is a straight line. So I'm going to say y equals mx plus c. And if I look at that, well, therefore m is minus EA over r, x is t, c is ln A, and y is ln K. So the gradient is minus EA over r. Therefore, I want to find out the activation energy. Minus EA is gradient times by R. R is 8.31. I want the activation energy kilojoules multiplied by minus 1. So then find out the gradient times by R. That will give me minus EA. Divided by 1,000. That will give me minus EA in kilojoules multiplied by minus 1. Divided by minus 1. That will give me EA in kilojoules multiplied by minus 1. Calculate heat capacity in G K to the power minus 1 when Q equals C Cal delta T. So first thing I'm going to use is Q is delta H by moles, 4154. That's how much kilojoules energy when combusted times by number of moles. Then I've got that to find out the heat capacity of that. Q over delta T, which is 12.4, and you should get your answer. But remember to divide Q No. You keep Q as it is. That's the tricky part because what a lot of students, including myself, would definitely do is convert Q into kilojoules because I want my final answer kilojoules. But I use Q as delta H and my moles. Delta H is in kilojoules. So Q, therefore, is going to be measured in kilojoules already. So therefore, it's just going to be Q divided by delta T, which is 12.4. Calculate heat energy change for octaneous combustion reaction. Well, I'm going to use Q equals CCl delta T and 7.79 times by 12.295, and then delta H is Q divided by moles, 95 over the number of moles, to mass over the gram, mass in grams over the mR. State by the heat change calculated from the bomb calorimeter experiment is not an enthalpy change. The pressure is not constant in bomb calorimeter. Pressure is not constant in bomb calorimeter. And if you recall the definition of enthalpy change, heat energy change at constant pressure. And the reason it's not an enthalpy change is because the pressure is not constant. Then it says calculate percentage uncertainty in the use of the thermometer. So it's going to be 0.1 divided by 12.2, but because I'm using two readings to find out temperature change final minus initial, I need 10 by 2, then 10 by 100 to get 1.64%. Suggest one change that decreases the percentage uncertainty while using the same thermometer. Use a bigger mass of fuel. So always apply it to the question. Use a bigger mass of what? A fuel. So delta T is greater. Use a bigger mass of fuel so temperature change is greater.